Hello, good afternoon, and welcome to a presentation of descriptive statistics with OpenOffice and Java. Today we wish to share something of value to our non-developers in the form of a review of numerical descriptive statistics using OpenOffice Calc. It's graphical descriptive statistics equivalent using the same tool and the use of Math Commons library for Java. So the data for which we want to generate statistics is a population of 60 Filipino male heights, which are typed in here at column A, and for it we want to categorize into three different classes the measures that we want to describe. We have the measures of central tendency, the measures of dispersion, and the measures of shape and form. For central tendency, we have the mean, which is nothing else but the average of the population. Median is when you sort the data at left here, find the middle value. When you sort it in ascending order, that's your median. And mode is the most frequently occurring data in the population. For dispersion, we have the maximum, which is the highest value, minimum, which is the lowest value, range, which is the difference between the maximum and the minimum, and standard deviation is one of the most important measures of dispersion. It may be simply defined as the difference or average difference between any point in the population or any observation within the population and the average. Before I move on to measures of shape and form, I first would like to demonstrate to you how to do descriptive statistics in the graphical way. So we have numbers here, but sometimes you want to be more visual in the presentation of data. So you go about it by first setting up a frequency distribution table by subdividing your range of values between maximum and minimum into several different categories or ranges. So to do that, you take your minimum, move slightly higher than that value, so I pick 59 since I have a 58.47 value for my minimum. 59. Then I could choose as the upper limit for my next bin 60, which is the next whole number, but in doing that I will be creating too many classes, so I instead pick 61 and then use the drag and drop technique to generate the other upper limits for my bin classes. Now we want to count the frequency of values falling within each of the bins, so I do that using a matrix formula called frequency. I enter it using the equal sign and then the name of the function, and then for it I need to supply two arguments which are data and classes. For data, I use the same data that I use to generate my numerical descriptive statistics, and for classes we select the range that we just created for our bin ranges. Now we have a table. We want to highlight those two columns and then select this graphical tool here. Choose the default column format by clicking next, and then we want to make sure that the data series is in columns and the first column as label selection is picked. So we generated more or less here a distribution that's normal in characteristic. We have a bell curve. We want to carry on with describing the shape and form of this. So we have skewness, which is a description of how heavy the tails are. We have a tail here at the left and a tail here at the right. We could see that we have a negative value. That means that we are heavier at the left tail end of the distribution rather than heavier at the right. Had we had a zero value, that means we have equal heaviness between the left and the right. For kurtosis, kurtosis is nothing more than a measure of the peakness of our distribution. We have a peak distribution if we have a high value right at the middle. Since we have a negative value, that means we are more on the flat side of the kurtosis. Zero value meaning that we have just about the right amount of peakness as a normal distribution would have. So that's a demonstration of how to generate statistics using OpenOffice. But what if you want to generate statistics and incorporate it in our Java programs? So to demonstrate that, the tool that makes that easy is the Apache Commons Math Library, available in the internet through this URL. What you do is download a zip file comprising the library, and then explode it in your preferred directory or your working directory, and then you want to make sure that the jar files that are generated from the explosion process are included in your class path. So I want to demonstrate that now. Prior to this presentation, I already set up a set class path batch file which sets up my class path. You could see the jar file is part of the path that I specified, and then I want to show you the program that I used to generate statistics using the Java programming language. So you could see here, what I did first was to import the descriptive statistics class from the library, and then create an object of that instance. By the way, I extended the descriptive statistics class and created my own class called stats from file. So that's inheritance at work. And then for that class I create a print stats method, which is nothing more than a conglomeration of all of the statistics functions that are available in the library. So I create this function or method so that when I call it, I could easily generate, using just one command, all of the statistics that I need. And then after creating the instance, I open up the file that contains the Filipino male height data that we used in OpenOffice, and then read it one by one. And then there's a facility for me to push all of those individual data into the internal data structure of the class that we created. And then at the end of the main function, I call out the print stats method that I just created for the class. Now to demonstrate that, we first have to compile the stats from file Java program. It's stats from file.java. You could see here that there's absolutely no problem looking for the library files, because we already included it using the class path batch file. And then we want to demonstrate using the Java compiler how the stats from file program works. You call it out and then supply to it a parameter, which is the name of the file containing your Filipino male heights. So what you could see here is we more or less generated the same summary statistics data from what we had in OpenOffice. So to review what we just went through, we discussed numerical descriptive statistics using OpenOffice Calc, generated the same descriptive statistics graphically using the same tool, and then we introduced the use of Math Commons library for Java. If you have questions, you could contact me here in Facebook. And thank you very much for viewing this presentation, and see you all in the next presentation.